Hello, in this video we are going to discuss the dielectric resonator antenna. The dielectric resonator antenna is a device that can both send and receive signals. Once I'm finished talking, Linford is going to start talking about the theory behind this device. In that discussion, he's going to make note of two main components: a dielectric resonator, usually composed of ceramics or glass, and a metal ground plate. The simplicity of this design is going to be covered in the feature section of our video, and that's going to be covered by David. In that section, he's going to discuss four main features of this device, that being that it has low conductivity, broadband connection, and that it's compact in design and simple in design. Devin is then going to take these features and relate them to the industry. He's going to connect that the low conductivity of the device makes it great for emergency situations. The broadband connection has wonderful Wi-Fi uses. Compact design means that the antenna can be placed in smaller and smaller devices, and the simplicity in design makes it very cost effective. Now I'm going to send it off to Linford, who is going to discuss the internal components of the dielectric resonator antenna.
There are two main components to a dielectric resonator antenna, that being the dielectric resonator itself and a metallic ground plate. The metallic ground plate serves as a safety net for the entire system in the event of an overload or any other issue. The dielectric resonator is traditionally made of ceramic, glass, or any other low conductivity material due to its high dielectric constant. The shape of the material will also define the potential waveforms that can be output by a dielectric resonator antenna. It could be any sort of 3D shape, such as a square-based prism, a pyramid, or any other 3D object. The dielectric resonator antenna works by having a transmitter circuit within the dielectric resonator itself, which then, when any sort of power is applied through the system, will create standing waves within the material, which were then output as a signal.
The dielectric resonator antenna has four features: low conductivity, broadband connection, compact design, and simplicity in design. The first feature is low conductivity. The dielectric resonator is a cylindrical low conductive material that is placed on top of a metal plate and is either made of ceramic or glass, with ceramic being the more popular of the two. The reason you want low conductivity is for less signal interference. For example, if you have a high current, there will be more noise in a signal that you're sending out or receiving, but if there's low current, you'll have a lower noise or possibly no noise interrupting the signal, which means that you'll have less signal interference.
Less signal interference is very useful for emergency situations and tracking. Less signal interference while broadcasting over larger areas is very handy for emergency situations because you're trying to get a lot of communication out to people in that in a rush time, right? So if you have that high interference, it will very hinder your ability to get that information out.
The second feature is broadband connection. The broadband connection is based entirely on the dielectric constant of the dielectric resonator, which, as I said before, is the cylindrical material that is placed on top of the metal ground plate. The dielectric constant changes with respect to the material, and you generally want a high dielectric constant in order to have a high broadband connection. And with a high broadband connection, you have a large range of different frequencies, from low to high. So in general, you will have a longer range of frequencies.
This is very useful in Wi-Fi because you can, all normal devices use it, right? And the frequency part helps you have multiple frequencies which multiple devices can connect to. Kind of like your Wi-Fi at home, some routers have like a 2.5 hertz and a 5 hertz, which provide different pros and cons. This also helps multiple devices connect to different frequencies, which would avoid interference by other devices, and you could connect devices to a higher frequency in order to avoid it getting interference from other ones.
The third feature is compact design. Generally, the dielectric resonator antenna isn't even that large. You can fit it in the palm of your hand or even smaller. That's why you can fit it in smaller devices.
This is very useful for phones and communication devices because you want smaller components that allows you to add more features to the phone or make it even smaller. This is also very good for military communication devices such as walkie-talkies and headsets because you also want those to be smaller. You also want those to be more compact.
The fourth feature is simplicity in design. Generally, as well as like in compact design, the dielectric resonator isn't that complicated. It has only three main components, the three being the metal ground plate, the cylindrical material that is placed on the metal ground plate, and the circuit inside, which is a relatively simple circuit. And that's why it's easy to build.
It also means it's very cost effective. The materials are very cheap. You don't need that many materials. You don't need that much of each material either, because you're just making such small components that you can make a whole bunch for very cheap.
So in conclusion, we believe that the dielectric resonator antenna is a small, relatively simple antenna that has countless uses in today's society. This video has been made by Nathan, Linford, Devin, and David, and we hope that you enjoyed. Thank you.